field inspection of sprayed fire protection materials indicates whether fireproofing meets the specifications for thickness, density, and bond strength. These are in-place performance characteristics that directly relate to the fireproofing's ability to remain intact on the steel for the design life of the structure and perform in actual building fire conditions. Inspection testing is one of the most important factors in assuring that the structural integrity of the steel is not compromised in the event of a fire. This video is intended to instruct the viewer by demonstrating the proper implementation of thickness, density, and bond strength test procedures which are essential for the evaluation of in-place spray-applied fireproofing products. You will need the following items: a scale capable of weighing the test specimen to within 1% of the specimen's weight, a rectangular template of known length and width having a minimum area of 144 square inches and being at least 6 inches in one dimension, a knife or other suitable tool for cutting the sample, a drying oven capable of maintaining 120 degrees Fahrenheit at no less than 50% relative humidity, a moisture meter capable of registering moisture content as low as 5%. Unexpanded polystyrene beads with a nominal diameter of 0.04 inches or size number 8 lead shot. A minimum 250 cc graduated cylinder. A funnel having a diameter of approximately 6 inches and a bottom diameter of approximately 1 inch. A minimum 400 milliliter beaker. A minimum 6-inch long rigid straight edge used as a screed. A deep-sided tray or pan. Thickness measurements should be conducted on a random basis in pre-selected areas in at least one bay per floor or for each 10,000 square feet of floor area, whichever provides the greatest number of tests. Testing should be done on one area of metal deck, one column, one primary, and one secondary beam, and one joist or truss. When measuring thickness, the test area must be free of physical damage and have a surface texture relatively free of excessively high or low points. Thickness is measured in a predetermined repetitive pattern, which ensures obtaining representative average thickness. For beam thickness, the points at numbers 1 through 9 are measured. For columns, measure at points numbered 1 through 12. Joists and trusses are measured at 7 points. For beams, columns, and joists, 2 sets of measurements are taken 12 inches apart. Measurements are taken by inserting the pin of the thickness gauge perpendicular to the substrate. When the pin touches the substrate, move the sliding disc to the material surface. Use sufficient force to register the average plane of the surface. If the indicator is allowed to rest on the top peaks or is pushed too far into the surface, inaccurate thickness readings will result. If the material is too hard to penetrate with the gauge, as may be the case with cured medium and high-density fireproofing, then a small diameter hole may be drilled, just large enough to fit the needle for thickness measurement. On flat decks, mark 12 points symmetrically within a 144 square inch template area that is at least 6 inches on one side, and measure the thicknesses. For fluted deck, mark the template area and take 4 random symmetrical measurements on each of the following: valley, crest, and sides, for a total of 12 measurements. The required thickness on crests, valleys, and sides may vary in some designs. In such cases, consult the underwriter's laboratory's design criteria. Individual measurements that exceed the specified thickness by more than 1/4 inch are recorded as the specified thickness plus 1/4 inch. Any area where an individual measurement is more than 1/4 inch or 25% less than the specified thickness, or where the average thickness is less than that required by the design, is considered a failed area and must be corrected by applying additional material. Each set of thickness measurements for the different structural members or deck section are then reported as a single average thickness. Underwriters Laboratories has conducted laboratory tests which have shown that a displacement method of determining the density of irregular shaped objects is more accurate than the standard calculated volume method. The Association of Wall and Ceiling Industries also recognizes the volume displacement method as an alternate to the calculated volume method. The volume displacement method is in the process of being adopted into ASTM E605. Based on superior accuracy, we have chosen to feature the volume displacement method as the primary method for determining density. Common practice is that density testing is conducted on each floor or each 10,000 square feet, whichever gives the greater number of tests on samples from any two of the following: column web, outside column flange, beam web, bottom of the lower flange of the beam, and flat portion of the deck. Carefully remove a sample by cutting to the substrate and prying the material from the steel. Dry the sample in an oven at a maximum temperature of 120 degrees Fahrenheit and a relative humidity of no less than 50%. Drying at temperatures higher than 120 degrees Fahrenheit will drive off chemically bound water and result in lower than actual density readings. The sample is considered dry when it registers less than 5% moisture on the moisture meter, or when the sample reaches a constant weight when weighed to the nearest tenth of a gram. Cut the sample to fit into the beaker with at least 1/4 inch of clearance on all sides. Weigh the sample and record the weight. Place the beaker into the pan and fill it with beads. Screed the beads even with the top of the beaker, being careful not to tap or shake it. Remove the beaker from the pan and empty the beads into the holding container. The beaker is now zeroed with the beads that are in the holding container. Set the excess beads from the pan aside. Place the beaker back into the pan and pour approximately 1/2 inch of beads back into the beaker from the holding container. Gently place the sample in the center of the beaker on top of the beads, making sure the sample is not touching the sides. Using the funnel, pour as much of the remaining beads that will fit from the holding container into the beaker. Screed the excess beads even with the top of the beaker, making sure all of the beads are caught in the pan. Remove the beaker from the pan. Combine the beads collected in the pan with the remaining beads in the holding container. Pour all of the excess beads collected into the graduated cylinder. Do not tap the cylinder. If necessary, gently move the cylinder side to side to level the beads. The volume of beads in the cylinder represents the volume of the test sample. Read the volume of beads in cubic centimeters, then calculate the density. Density measured in pounds per cubic foot equals dry weight in grams, multiplied by 62.43 divided by volume in cubic centimeters. To measure density using the calculated volume method, use the following procedure. Place a 144 square inch template that is at least 6 inches on one side against the material surface and score around the template. Mark 12 points symmetrically within the template area and measure the thickness. Cut through to the material surface where the surface was scored. Without losing any material, carefully pry the test area from the substrate and collect it in a plastic bag. Dry the sample in an oven at a maximum temperature of 120 degrees Fahrenheit and a relative humidity of no less than 50% until less than 5% moisture is detected by the moisture meter or a constant weight is obtained. Record the weight of the sample and calculate the density as follows. Density, measured in pounds per cubic foot, equals the weight of the dried material in grams multiplied by 3.806 divided by the length of the sample in inches, multiplied by the width in inches, multiplied by the average thickness of the sample in inches. Whenever this test method results in a lower than expected or acceptable value, the more accurate displacement method should be used to confirm results. It is common practice to conduct one test for beams and one test for decks for each 10,000 square feet of floor area, with a minimum of 2 tests per floor. The following materials are needed to perform the bond test: A moisture meter capable of registering moisture content as low as 5%. Two-component urethane adhesive. Rubber gloves. Jar caps that are between 2 and 3.5 inches in diameter with a depth of approximately 1/2 inch. Small screw eyes. A spring scale with a hook attachment and a capacity of 60 pounds. An awl or small diameter nail. The hooks should be inserted into the caps prior to arrival at the job site. Using the awl, punch a hole in the center of the cap and insert the screw eye into the hole. Prior to testing, the fireproofing material must be fully cured and dry. Material should have no more than 5% moisture as measured on the moisture meter. Pour one of the two adhesive components into the bottom of a cap. Pour an equal amount of the second component into the cap and mix thoroughly. The urethane must be warm to work properly. As soon as the urethane begins to react, press the cap firmly against the surface of the fireproofing in the center of the test area. Hold the cap in place until the adhesive has adequately cured. Wipe away excess adhesive before it cures, or cut it away after it has cured, being careful not to disturb the fireproofing below. Hook the scale into the screw eye. Slowly increase the amount of force applied perpendicular to the surface until failure occurs, or the capacity of the scale is reached. Record the weight registered on the scale at the time of failure. Calculate the bond strength using this formula. The cohesive adhesive force, measured in pounds per square foot, equals the recorded force in pounds divided by the area of the jar cap in square feet. It should be noted that the bond strengths of some high-density fireproofing materials may exceed the capacity of this procedure for job site testing. In such cases, alternate test equipment may be employed. This video is designed only as a teaching aid and is not meant to supersede any testing or approvals required by authorities governing the use of fire protection materials. These tests do not in themselves constitute a fire rating, nor do they indicate any specific degree of fire protection to be obtained by their use.